Let's learn the basics of how to Dockerize a Django application alongside a Postgres database container. So what we're going to do in this video is take a couple of different Docker images, the Python image and also the Postgres image, and we're going to create containers from them in order to Dockerize a Django application that can connect to that Postgres database. So this is going to be a deep dive on this, and we're going to cover a lot of the basics on how to set these up. Now before we start, if you want to support the channel, check out the Ko-fi page we've got just below the video. And thank you again to everyone that's contributed to this, it's greatly appreciated. So let's get started and dive in. Now what we're going to do is set up a basic Django project from scratch. So let's open VS Code, and you can see here that I have a directory and there's a source directory within that is currently empty. So let's cd into the source directory and we're going to install Django in that. Or rather what we're going to do is we're going to start a Django application. So I've activated a virtual environment for now, and we're going to run the Django admin start project command in order to initiate a Django project. And let's call this Django Docker demo, and we're going to put that into the current directory, which is the source directory. Now you should see on the left hand side within the source directory that creates some files and directories. We have the manage.py script and we have the project folder here containing the settings and so on. Now we have the manage.py script in this directory, so let's run python manage.py, and this time it's the startup command. And this can be used to create an application within the project. We're going to create one called core. Now this is a demo in a real application. You might want to give it a more descriptive name. What I like to do is use the core application for any common functionality across different apps, but that is just a preference. So let's clear the terminal. And one last thing before we create a Docker file, I'm going to go to settings.py and we're going to add this core application to the Django installed apps. So let's do that just now and we can save that. Now normally when you run the run server command, you start the Django development server on your local host. What we want to do is have this running inside a Docker container on our host. So we need to actually tell the Docker container how it's going to be set up, what image it should extend, and the details for how to run the Django application. Now in order to do that, we create what's called a Dockerfile. And a Dockerfile is essentially a document that contains all of the commands in order to assemble an image from which you can then run containers. So you create the Dockerfile, you then build an image from that, and from the image you can run one or more containers, and each container is its own kind of isolated environment. So the image, you can think of that as like a blueprint or a snapshot from which you can then create any number of containers in order to actually run your Django application in this case. Now in the root folder just above the source directory, what we're going to do is create a Docker file here, and you can see in VS Code it picks up what this file should be. And we also get the message down here that Docker is not currently running. Now the first step that we need to do here in the Docker file is extend an image. We're going to run a Django application, so we need to have a Python based image. I'll leave a link to this page below the video. It's the official Python image on Docker Hub. And what we're going to do if we scroll down is we're going to extend one of these images. Now you can see Python 3.14 for example is here. We're going to use 3.13 for this video. And I'm going to select this one here. It's the 3.13.3 𝗬𝗵𝗽𝗶𝗹. So that's one of the images provided by Python. And bookworm, if you're wondering what that is, it's based on Debian Linux version 11. So this image will have essentially an operating system of Debian Linux, and we're going to create our own image based off of what's provided by that image. So we're going to use the from directive in the Docker file, and we're going to extend 3.13 𝗬𝗵𝗽𝗶𝗹. So this is normally the first step in your Docker file. You choose the image you want to extend. We have a Django app, so we're going to use Python. But if you were building a Go application, you would use a Go image. And if you were building some kind of Node.js application, for example, you would choose a different image for that. And Docker Hub has images for all sorts of different programming languages as well as different systems. For example, Apache Kafka, you can extend that, you can extend Apache Spark, and all of these different tools. Now once we've added the base image, we can then start to assemble the commands to actually create our own image that's capable of running the Django application. What I want to do to start with is set a couple of environment variables here. And in a Docker file, you do that with the env instruction. And I'm going to paste these in here. So we have two environment variables. One of them is called Python don't write bytecode. And we set this to 1, which means that it's not going to write these bytecode files to disk inside the Docker container. And these are the .𝗏c files that you see appearing on the disk sometimes. So that's not going to be written to the container, and sometimes that's what you want. We also have Python unbuffered, and we're setting that to 1 as well. This is going to prevent Python from buffering output to standard output and standard error. And by setting this to 1, this allows for log messages to be immediately dumped to the output rather than being buffered. And that's useful in development because you then get your log messages immediately appearing on the terminal. They're not being buffered. Now these are two environment variables I like to set in the Docker file. This one in particular I think is useful for development. And what we're going to do now is set a working directory with the workdir instruction, and we're going to set that to a directory called app at the root of the file system. So within the Docker file, this workdir statement here is essentially like a cd command on your local file system. It sets the working directory for any subsequent add, copy, and so on instructions. So anything we do below this statement in the Docker file, unless we change the working directory or specify an absolute path, it's going to approach that as if it was from the app directory. Now what I want to do now is install some dependencies for this project. And these are going to be system-based dependencies to begin with, and then we're going to install Python dependencies from a requirements.txt file, and we're going to use UV for that. Now let's go to a page on using UV in Docker. And if you want to know more about this, check out the video we did on UV in Docker. If we scroll down on this page, you can see how to install UV inside a Docker image. We have this copy command here, and we're going to copy that into our container. So I'm going to paste this in just below the work directory for now. And what this is going to do essentially is take this image here, and it's going to copy UV and UVX into the image that we're building here in this Docker file. That's going to make both UV and UVX executable from the command line inside this container. Now I mentioned installing system dependencies. We can do that using the run command, and because we're on Debian Linux, we can use apt-get to install packages for the operating system. So for example, you might want to install curl for making requests. And you can basically install anything you want here. It depends on what you're going to try and do within the container. And another example of something you might want to install is 𝗵𝗽𝗃𝗃. And that's something that you can use to communicate from your Python application to a Postgres database. However, we're not going to need that, so I'm going to remove that, and I'll explain why we don't need that in a second, even though we are going to connect to a Postgres database. Now at this stage, after the copy command here, where we install UV, we want to also copy some files from the local directory into the container. So I'm going to use a copy statement here. And what I want to copy in the source directory is a file that I'm going to create in a second called requirements.txt. And we want to copy that into the working directory, so we can just place the single period here. And let's create the requirements.txt file now within the source directory. Now to set up Django with a Postgres backend, I'm going to add two packages here. One is Django itself, and the other one is 𝗖𝗵𝗽𝗁 binary. Now I'm going to open the documentation for 𝗖𝗵𝗽, and this is the driver that's used by Python applications to communicate with a Postgres database. Now a lot of the online tutorials use 𝗖𝗵𝗽 version 2, but that has been updated now, so instead of version 3, it is now just 𝗖𝗵𝗽. And this binary that we're adding here to the 𝗖𝗵𝗽 package, this is a pre-compiled binary, and that's useful for development. In production, you wouldn't want to use that, but you will need to install the 𝗵𝗽𝗃𝗃 in order to use 𝗖𝗵𝗽 without the pre-compiled binary. So we're going to use this binary for development, and in the Docker file, we're copying the requirements.txt file into the working directory in the container, which is the /app directory. Once we've done that, we can use another run command. And what we're going to run here is the uvpip install command. And we're going to pass the requirements.txt file into that. And I also want to pass the -- system flag. And what that's going to do is use the system Python. We're not going to create any virtual environments here because this is inside an isolated environment anyway, inside a container. So we don't need to worry about creating virtual environments. So we're using the uvpip interface to install the requirements from this file that we've copied into the Docker image. And then once we've installed the requirements, what we're going to do is copy the rest of the source directory into the Docker container. So I'm going to copy this here, and we can paste it just below the run command. And we're going to copy the entire source directory into the working container of this Docker image. Now you might be wondering, why do we copy requirements.txt from the source directory and then run the pip install command and then copy the rest of the source directory in? Why not just copy all of the source files above this uvpip install command? And this is actually a Docker layer caching optimization. So Docker will build this image in layers, and it's a best practice to copy and install dependencies in a separate step before you copy the rest of the code into the image. And that gives you a big performance boost during rebuilds. So if anything changes in your source files, only this layer and the ones below it are going to have to rebuild, and it's not going to have to install all of the requirements. So that is a best practice. There's only two more commands I want to use here. So we're going to expose port 8000 inside the container. And this is a declaration. It's not an actual network binding, but it's useful to declare, and it's used by some of the tooling around Docker. And the final thing we're going to add here is the command. And this sets the default executable and any parameters for this executing container. And I'm going to paste this in here. So we're running python manage.py run server, and we're running on port 8000. Now, why do we have all these zeros? What this is going to do is tell Django to listen on all network interfaces, not just on localhost. And that's important when you're inside a Docker container. If we don't add this, Django is only going to be accessible from inside the container itself. So what we're going to do is essentially run a container here with a Django application from this image. And we're going to connect to that running Django application inside the container from the host machine. And that's the machine that's actually spinning up the Docker containers. It's a separate environment, but in order to access the Django application, we need to add this here. So this is our initial Docker file, but we want to also add a Postgres database. What we have here is only for the Django web application. These are the instructions for the Django container that uses Python, and it installs the Python requirements needed for this web application and has this command to run the Django server. But we also want to use a Postgres database container, so that's where we set up a docker compose.yaml file. Docker Compose allows you to bring together multiple different containers that are running different services. For example, the Django web application is one container. We're also going to create another container for the Postgres database. And Docker Compose could allow you also to spin up multiple containers for one of these. For example, you might have a single Postgres database, but you might want to spin up 5 or 6 or 7 or however many Django containers for your web application. And you could also add containers for caching services like Redis, and basically anything you want. So in the docker compose.yaml file, we're going to have a top level block called services. And we're going to create a service for our Django web application. So it's going to be called web. This is the name that we're giving to this service. And we're going to specify a build directory here that's going to look for a Docker file, and that's going to be in the current directory because the Docker file is alongside this docker compose.yaml file. So this basically means when it's building the web container from the image, it's going to use this Docker file here that it finds in the current directory. We're also going to create a name for the container that we're going to build, and it's going to be called Django app. You can call that whatever you like in that value. And we're going to expose some ports here. So this is going to be a port mapping from port 8000 inside the container to port 8000 in the host. And finally, I want to create a volume as well, and we can use the volumes key for that. And we're going to mount the source directory on the host into the working directory of the container, which is the app directory at the root of the file system. What this means is that when we change any files on the host inside the source directory, and we're going to do that while we develop the Django application, those changes are going to be reflected in the app directory inside the container because we have this volume. This is important for development because when we change some of the files to build the Django application, we don't want to have to rebuild the entire Docker container. Instead, when we change the files in the source directory, we want to automatically update the app directory. So let's try this out. In order to do it, you need to have Docker running on your operating system. Now I'm on Windows at the moment, and if you're on Mac or Windows, you need to have Docker Desktop running. And you can see I've got this starting up just now. It's Docker Desktop. It's starting the Docker engine. And once that's started, what we're going to do is run a command. Because we have a Docker Compose file, we can run a command docker compose up, and we're going to pass the -- build flag to that. And what this is going to do is it's going to build the image for all of the services that we need here. So we have this web service here. It's going to build the image from this Docker file. And then once it's built the image, it's going to spin up a container or any number of containers for that service based on what's in the docker compose.yaml declaration. So let's run this command just now. And what we're going to see here on the terminal is this message, which I didn't expect, and it says empty compose file. I think we need to go back a directory before we run this command. So let's try this again. And we still have no output, and it's a very simple problem. We haven't saved the docker compose file. So that's my mistake. Let's try again the docker compose up command, and it's going to then create that image. Now you can see a lot of things going on here, and that's basically pulling the source image from this Docker file, which is the Python 3.13 image. And you can see we get an error at stage 3 here, and that's where we have the apt-get install curl command. And what I'm going to do is add another apt-get command here. So we're going to add the apt-get update command, and that's going to update the package indexes, and then we can run apt-get install curl. So if you get errors like this during the build, you can Google them and you can see the Stack Overflow answer, and I've got one here for this. If there's no package cache inside the image, you can run apt-get update. After you've done that, you can then install packages inside the Docker file. So we've updated the Docker file now. Let's go back and we're going to try this command again. And let's see this time if that's going to work. And at the end of that process, we now have the Django web server running. And if we go to localhost 8000, you can see we have the Django page here. So we're connecting to this Django application that's running inside the Docker container. And we've exposed port 8000 on the container. And we can do that because we have this port mapping between port 8000 in the host and the container, allowing us to connect into the container and access the Django application. Now what about PostgreSQL? So what we have here at the moment is just a Django application, but we want to connect to a Postgres database and use that as our data store. Now at the start of the video we showed this Postgres image from Docker Hub, so let's go back to this page. If we scroll down we can see the supported tags and Dockerfile links, and the latest version of Postgres is version 17.4 at the time of recording. So what we're going to do in the docker compose.yaml file, if we go back here, is we're going to create a second service called db, and again you can call that whatever you want. And this time we're going to directly extend an image, and that's going to be the Postgres image, and we're going to use version 17. So we're not using a local Dockerfile here for the base image like we did above with this build directive. Instead we have an image that we're specifying directly from Docker Hub. And when we create the container from this image, what we're going to do is give it a container name of PostgresDB, and we're going to create some volumes as well. So I'm going to create what's called a named volume, and it's going to be called PostgresDB. So that's going to be on the host, and we want to map that to somewhere inside the database Docker container. Now the directory we're going to use is this one here. It's the var/lib/postgresql/data directory. And this is where the database data files are stored. And this named volume called PostgresDB is going to allow the database data to be persisted beyond the lifetime of the container. So if the container stops at the bottom, we don't want to lose all of our data in development, so we create a named volume here, and then the next time the container is spun up that uses this named volume, we're going to have that data available. Now before we go on with the database image, I'm going to add a top level volumes directive at the bottom, and we're going to specify PostgresDB down here, and we can leave that as is, and that's going to pick up that volume. Now if we go back to the Docker Hub documentation for Postgres and scroll down to this section at the bottom on how to use the image, you can see that in this command here, which is a docker run command, that's a different way of starting a container from an image, we have a Postgres password being passed into the container. Now this is a required environment variable, and if we scroll down further we get more information on the environment variables that are available. We're going to set some of these, so Postgres password is required, we're going to set that. And we're also going to set the Postgres user and database environment variables. Now we can declare an environment block within the docker compose.yaml file, so let's do that just now. Environment, and this is basically a list here that contains a bunch of names and values. The name is the name of the environment variable. So for example, we can paste in Postgres password here, and what I'm going to do is read these from a .env file, and we can use this interpolation in order to do that, although I do need to use the correct YAML syntax. And we're going to read a value from the .env file called Postgres password. Now if we go to the Docker Compose documentation, a .env file in a Docker Compose is a text file that's used to define variables that should be made available for interpolation when you run the Docker Compose up command. I'll leave a link to this below the video, but basically it allows you to use this syntax here, and you can refer to values that are in a .env file. So what we're going to do in the source directory is we're going to create a .env file, and actually this should be at the top level directory alongside the Docker Compose file. And I'm going to paste some values in here, so we're going to create a PostgresDB, Postgres user, password, and we're also going to create variables for the DB host and port that we're going to use in the Django settings.py file. Now for the Postgres database, we want the top three. We've already read in the password here, so in the environment block, I'm going to paste in two more. So let's add these just now. The PostgresDB is going to be equal to the value from the .env file, and also the Postgres user, that's also going to be equal to the value from the .env file. And I want to add one last block here, and that's going to be the health check. And you can see the auto filling out from VS Code here. So what are we going to put here and why? Let's go to the Docker documentation here, and we have a section on controlling the startup and shutdown order in Compose. Now the reason we want to do this is because when Django starts up in this web container, it's going to try and connect to the Postgres database, but we need that database to be set up and active in order for that connection to be successful. Otherwise, the Django application is going to error out and stop the container. So basically, we have a defined startup order here. We want the database to be started before we start the web container. So in the web container, we're going to add a block here called depends on, and it's going to depend on this database service that we have. And I'm going to remove this here. We're just going to use the tab. And in the database service, what we can do is we can specify a condition, and it's going to be the service_healthy condition. And we can also pass restart as true. So let's break this down. The condition is service healthy. Let's go to the documentation and let's have a look at the startup section here. So on startup, Compose does not wait until a container is ready. only until it's running. And that can cause issues if you have a relational database system that needs to start its own services before being able to handle incoming connections. That's exactly the problem that we have here. So the solution for detecting the ready state of a service is to set the condition attribute with one of these values. Service started, I think, is the default. Service healthy is the one that we've used, and that specifies that a dependency should be healthy. And that health is defined with this health check block that we're going to define here inside the database service. So we have a health check here. And when this evaluates to true, only then are we going to start the services that depend on that. In this case, that's the Django web service. Now, as well as the condition, we also have restart true here. And what this means is that if the database service restarts, and that could be due to an explicit Docker Compose operation, for example, then the web service that we have here is also automatically going to restart because we've added this block here. So let's now define the health check just below here. And it turns out Docker Compose has an example here. So if we go down to this block, this is a Postgres database service here, and we're going to copy the health check and we're going to paste that into this block here. And it's using this 𝗵𝗳 command. Now this is something that PostgreSQL database provides. So 𝗵𝗳 is going to check the connection status of a Postgres server. So we're going to use that and make sure that the server is ready to accept incoming connections. That is the health check. And once this health check evaluates to true, then we are going to start the web service. Now, before we try and start the database service alongside the web service, what we're going to do is go to settings.py, and if we scroll down to the databases setting here in Django, this is currently using an SQLite backend. We need to change that to use Postgres. So what I'm going to do here is just import the OS module from Python, and you would probably want to do this at the top of the file. And I'm going to change the databases setting here to read these values from the environment. So first of all, we're going to use the Postgres backend, and this is the engine key in the default database. We also have the name of the database, and we're using the values from the environment file, PostgresDB, Postgres user, and Postgres password. And we also need to specify the host and the port for this connection to PostgreSQL. Let's go back to the .env file. Notice that the database host is set to DB. So when you're inside this Docker environment, what you can do is essentially specify the name of a service, and Docker Compose is automatically able to resolve that host name. So all we do here is specify DB, and then we're reading that into this environment variable here and using that in the databases setting. And you can see the yellow underline here, and that's coming from 𝗏, which I've got installed in VS Code. So let's just move that to the top here, and we can paste that in. Now, to actually get the values from the .env file, we need to go to the dockercompose.yaml and go to the web service, which is the service running the Django application. We already saw in the Postgres service how to define environment variables, but we can also define an env file here. So let's add that key to the web service, and we're going to map that to the .env file that we have here on the file system. So we're ready to now test this out, and hopefully that's going to work out of the box. Let's clear the terminal, and we're going to run that docker compose up command, and that's going to start both the services. Now I'm getting an error that the environment must be a mapping. So what I'm going to do is have a look at this key here in the Postgres service. Now I think all we need to do is get rid of these dashes here. So let's do that just now. So this is now a mapping. Let's try this again, and we're going to go to the terminal and run docker compose up. And it's going to pull that Postgres image from Docker Hub to start with, because we haven't run this command before. So it's going to get this image from Docker Hub, and that's going to serve as our PostgreSQL database image, from which we are going to spin up a container using this Docker Compose file. Now you can see as it's progressing through this that the Postgres database server is being started up. And when that's ready to accept connections, as you can see down here, this health check is going to kick in, and it's going to evaluate to true. And when that's the case, and the interval for that is every 10 seconds, it's then going to start the web service that you see up here. And you can see that at the bottom now. So that comes after the database service is ready to accept those connections. And that's based on that health check that we defined here. And if we go to our web application, you can see everything is still running fine. Now to test this connection to the database, what we're going to do is go to the Django application. Now we created this core app, and we're going to go to models.py. And let's create a model here within this, and I'm going to paste some code in. This is going to be a model called actor. And each actor has a name, a nationality, and a date time when this row was added to the database. Now while these containers are running, we're going to open a new terminal here. And we need to make the migrations associated with this new model that we've created. So we're going to connect directly to our container, our Django container, which has got a container name of Django app. So what we can do here is run the docker exec command, and we're going to paste in the name of the container that we want to connect to, which is called Django app. And then after that, we can run any command we want. So we're going to run python manage.py, and it's going to be the make migrations command. So we need to run this using docker exec because this Django application is not running locally, it's running inside the container. So this connects to the container and it runs that manage.py command. As you can see here, we're executing that command and it creates the migration file. And because we have this volume from the source directory to the app directory, when that makes the change inside the container, it creates that initial file here for the migration, and that is reflected on the local file system. Once we've done that, we can run the migrate command. It's very similar. We just copy docker exec, we paste that in, and this time it's going to be the migrate command. And this time it's going to try and connect to the Postgres database and apply those migrations. And you can see that core migration at the bottom, alongside a bunch of the other Django migrations. These are built into apps such as auth. After running the migrate command, all of those tables should now be available inside the Postgres database. So we have a database that we want to connect to called dev database. What we're going to do is we're actually going to connect to the other container now. So when we run docker compose up, it creates the Django web container, but it also creates the database container as we saw. And that's got a container name of PostgresDB. So let's go to the terminal again. And again, we're going to run the docker exec command. And we want to connect to the Postgres command line utility and then run commands. Now, in order to run multiple commands and have a session opened inside the container, we need to pass the -ti flag. And then we can pass the name of the container we want to connect to. And this time we're going to run the PSQL command line utility. We have a user of bug bytes, and that matches what's in the .env file for the Postgres user. And we're going to connect to a specific database using -d, and we're going to copy dev database here and paste that in. And that's going to then connect us to the Postgres command line utility, and this is running inside the Postgres Docker container. Now we can display tables using the /dt command, and you can see all of the tables that have appeared in this database. Among them is the actor table from that model that we created. We also have things like the user table and permission table. And if we take the actor table here and we can run a select statement, select all from core actor. If we execute that, at the moment, of course, we're not going to get any rows returned here. But what I'm going to do is create another terminal on the right hand side, and we're going to execute this command in the Django container. We're going to connect to the Django shell using python manage.py shell. So let's execute that. And again, we're using -ti here so that we can maintain the session. And notice we have the shell and we have objects imported automatically, and that's due to the automatic model imports in Django 5.2. If you want to know more about that, check out the Django 5.2 video we did that's appearing on the screen now. And that means our actor model should be automatically imported, as you can see here. And I'm going to create 2 actors on the command line. So I ran this statement here and the formatting's a bit off, but you can see we've created an actor for 𝗵𝗽𝗁 and also one for Michael Caine. And if we go back to the PSQL command line utility and we rerun that select statement that we have here, this time when we execute that, you can see we have 2 rows in the database table. So this actor table is now populated with data that's being executed using the Django ORM. Django is running inside a Docker container. It's connected to a Postgres database running inside a database container. So these are 2 containers, and we're coordinating those using a docker compose.yaml file. So at this stage, what I want to do is just stop the server here. So let's go back to one of these terminals, and we're going to stop the docker compose process. And to finish the video, I want to just demonstrate something very quickly. Sometimes you want to create your own custom entry point script for the Docker command. So if we go down here to the command, currently we're running the python manage.py run server command. But what we might want to do is run multiple different things here. And in order to do that, it's best to have an entry point script. So I'm going to create one just now called entrypoint.shell. And I'm going to paste some code into this. So what we're doing here is we're running the migrate command. So in this process, we're going to run the migrate command, and that's automatically going to apply any changes to the database when we run docker compose up. And after that, we're going to run the manage.py run server command, and we're starting that on the same interface as before. Now, if you're on a Linux system, you can make this entrypoint.shell script executable using the chmod command. And you can see that command on the screen just now. That makes the shell file executable, which is something you're going to need to do. And then if we go back to the Dockerfile, instead of this command here, we can just remove that and we can paste in the entrypoint.shell script. Now, the reason this might be useful, if we go to the entry point, we're running the migrate command. And let's assume you're working in a team. You pull some code that another developer has put on GitHub, and they've made changes to the models. You want those changes to be migrated locally when you start up the Docker compose process. So adding this here is going to allow you to do that, and you could also add collect static and other commands as well. So we now have this entry point. Let's restart the Docker Compose process. And again, it's going to wait till the Postgres service has started up. So let's very quickly simulate this. We're going to go to models.py and I'll paste in a new field on the actor model. So that's something that would have been committed by another developer. And then if we go to the other terminal, we can run the make migrations command. That will create the migration file that the developer will then push to GitHub. What we can then do is go back to the running container here. We're going to stop this and we're then going to run Docker Compose up and rebuild the container. And we're hopefully going to see that that automatically runs the migrations based on what we have in the entry point. So let's run the Docker Compose up command and I'm going to pass the build flag to that. And that's going to recreate these processes and it's going to start with the database as we saw before because of that health check and the defined starting order that we have here. So we have the health check and we have the web service that depends on the database. Notice here that it's running the migrations and applying that new migration that was created by the other developer. And this is convenient when you start your services after pulling code. That'll automatically run the commands in the entry point, and this time that includes the migrate command. So this setup now works. We have our Docker file for our Django application that's extending a Python-based image. It uses UV, as you can see here, and we're using 𝗵 pip install along with the --system flag. And we're coordinating the Postgres database alongside Django using a Docker Compose.yaml setup. So we have a web service for Django and we have a database service for our Postgres database. And these are using environment variables, as you can see here, for Postgres environment variables as well as for the container for the web Django application. Now I want to quickly note some changes you might want to do for production. So if we go to the entry point, we're running the Django development server. In production, you might want to use something like 𝗬unicorn or unicorn, however that's pronounced. And if you have an ASCII-based application, you could use something like 𝗬vicorn for that. And if you're using Django channels, you might use something like Daphne here. In production, you also might want to use collect static somewhere in this process and also use white noise potentially for serving your static files. And you might want to add to your Docker Compose setup to also have Nginx, for example, if you're serving your static files using Nginx. The Nginx container can then sit in front of the Django application that's running with 𝗬unicorn. And that can handle things like serving those static files if you're not using white noise, as well as things like SSL termination and reverse proxying. Now, if you'd like to see any extensions to this, let me know in the comments. And if you have any further requests, or if you've seen any mistakes in this process, then let me know in the comments as well. This is a setup that I think is good for development, but there's lots of ways you could extend this. And as I said, if you're using Redis for caching, or potentially Redis and RabbitMQ for celery tasks, you would probably extend the Docker Compose setup to include those services and any others that you're using in your web application. So thanks very much for watching. If you have enjoyed this content and you want to support the channel, check out the Ko-fi page that we've got just below the video. Thanks very much to everyone who has contributed to that. And don't forget to give the video a thumbs up and subscribe if this content has been useful. Thanks very much, guys, and we'll see you in the next video.